Hello everyone. So today's topic of discussion is the basics of exponents. So what we'll be doing in this topic is that I'm going to be explaining you the basic properties, basic relationships pertaining to exponents. How does this chapter work? So particularly this chapter doesn't have much of a theory. So once I have given you the relationship, once I've explained you the formulas, you just have to memorize those things. Let me be very frank to you. In the start itself, there are like 6 7 formulas which you need to remember, couple of which you already would be knowing. And once you do that, then I'm going to explain you what's the important thing is. You need to understand how to use them while you're solving questions, right? So there are like very small things which you need to know if you want to master this chapter. Okay, there is no one thing, and it plays a really important role when you talk about your exam, because a lot of questions can be framed using exponents in other topics also. All right, so first we're going to go through the basic rules of exponents, which probably most of you would already be knowing it, and then we'll be solving some 9 10 questions based on those. And then there are like couple of results, 4 5 important results which you need to remember, so we'll be discussing those results in detail also. And then last but not the least, then we'll also be discussing the rationalization concept. Okay, all right, so let's start. So some of you must have learned this chapter under the name of surds or indices also. So it's one and the same thing whether you call exponents, surds or indices, there is no difference. All right. So let's begin. So when we talk about this chapter, exponents or surds or indices, there are two things which are very important. The first one is known as the base and second one is known as the power. So anything when you talk about exponent, the general form of writing in expression in exponent form is a to the power of m, is a to the power of m, where a can be positive negative 0, m can be positive negative 0, but at the same point of time a and m cannot be 0, because 0 to the power 0 is not defined in maths. All right, so anything in exponents can be written as a to the power m, where a is known as base and m is known as the power. All right, so for example you can write something like 2 to the power 3, 3 to the power minus 2, minus 4 to the power 8, minus 5 to the power minus 6. These are all known as exponent form of an expression, each one of them. All right, now when you write something as a to the power m, what does that mean? What does a to the power m mean? So when you write a to the power m, so that's like multiplying a m times. That's like multiplying a m times. For example, if you write 2 to the power 3, that's like 2 into 2 into 2. If you write 3 to the power 4, so that's like multiplying 3 4 times, and so on and so forth. If you have a negative sign in the power, then there's a property which you need to know. However, the concept is still the same. Okay, so there are like 4 5 basic properties which you need to know for exponent. So let's start with them. The very first is, if you write something as a to the power m multiplied by a to the power n, this becomes a to the power m plus n. Okay, if the base is same and two things are multiplied, then the powers are added. For example, if I say 2 to the power 6 plus, sorry, not plus, 2 to the power 6 into 2 to the power 5, so this will become 2 to the power 11. Okay, if you want to know like why did I add this, how did I come to this conclusion that when you're multiplying the powers are added? So let me give you a simple example just for realization. I'm not going to give you the proof, it's not required. So let's say I am doing 2 cube 2 square into 2 cube. Okay, so let's not add the powers, let's simplify this expression. If I'm going to simplify this will become 4 into 8, which is equal to 32, which will nothing be equal to 2 to the power 5. So what is 3 plus 2 equal to? 3 plus 2 is equal to 5. If this question crosses your mind that why did I add the powers in this case? So here is an example or an easier way to understand this. Okay, just remember this. Second property which we need to know for this exponent part is, if you write a to the power m divided by a to the power n, this is equal to a to the power m minus n. Same way you can do like 2 cube divided by 2 square. 2 cube is 8, 2 square is 4. What is 8 divided by 4? That's 2, right? So 2 cube divided by 2 square, that is 2 to the power 3 minus 2. That is 2 to the power 1. Okay. Third is a to the power m whole to the power n is equal to a to the power m into n. A to the power m whole to the power n is equal to a to the power m into n. So in this case the powers are multiplied. You can again take an example for this. You can again do like 2 cube and put 2 cube whole to the power of square, so that's 8 square, which is equal to 64. What is 64? 64 is nothing but 2 to the power 6. So in this case the powers are multiplied. Fourth property, I'm going to like remove couple of things from my board. Fourth property is a to the power minus m can be rewritten as 1 over a to the power m. For example, if you have 4 to the power minus 2, then I can rewrite this as 1 over 4 square. Then I can rewrite this as 1 over 4 square. Fifth one, if you write something as mth root of a, like you must have seen like square root of some number or cube root of some number or fourth root of some number or 10th root of some number. So mth root of a can be written as a to the power 1 over a. Can be rewritten as a to the power 1 over a. For example, if you write like the fourth root of 5, so that is 5 to the power 1 by 4. That is 5 to the power 1 by 4. One more basic property which we need to know. If you write something as a to the power 0, this is always equal to 1 provided that a is not equal to 0. Any number to the power 0, any number on real number line, anything that come across your mind apart from 0, when you raise it to the power 0, it's always equal to 1. For example, minus 5 to the power 0, 4 to the power 0, 8 to the power 0, 10 to the power 0, minus 1000 to the power 0, 17 by 36 to the power 0, anything. That is always equal to 1. Okay? These are the 6 basic properties of exponents which drive this chapter. You need to like memorize them by heart. Now the problem is not the memorization as I have understood over my course of teaching career. The problem is not memorizing this. The problem is how to use them while solving the questions. So what I have done is I've picked like 9-10 basic questions for you, which may not come in your exam, but once you understand these questions, you will be able to at least think logically on how to use a specific property in a specific question, right? So let's start. We'll start with the first question. So the question is, n to the power n is equal to 2 to the power 32. Sorry, my mistake. N is equal to 2 to the power 32 and n to the power n is equal to 2 to the power k. You need to find the value of k. And based on that, 4 options will be given to you. Okay. So what I would suggest you is that as soon as I pen down a question on a screen for you, please pause the video. Try the question yourself, whatever you can solve. It doesn't matter even if it's 1 step, 2 steps, or till the very end. Solve the question, try it yourself, then play back the video so that you understand how to solve or what part you were missing. See, when you talk about maths is a subject where usually the problem comes in bridging the gap between the theory and the application part. If you read it as a storybook, you will never be able to understand maths. You need to pick up your pen, you need to solve questions. Okay, and exponents is one of those chapters where you need to actually pick up your pen and start practicing. Otherwise, you will never understand this chapter. Alright, so try this question. Alright, so I believe you must have tried this one. So let's see what we can do with this one. So I have n to the power n, which is equal to 2 to the power k. So I can write n to the power n as 2 to the power 32 whole 2 to the power 32. Okay. Now, if we go back to the previous slide. So if you see this property number 3, right? A to the power m whole to the power n is equal to a to the power m into n. So I'll be able to rewrite my expression as 2 to the power 32 into 2 to the power 32. Now, I can also rewrite 32 as 2 to the power 5. And then if I go back to the properties, if you use the first property, a to the power m into a to the power n is equal to a to the power m plus n. And if you use that property in the power here, then you will get this as 2 to the power 37. Now compare this with 2 to the power k, you will get the value of k as 2 to the power 37. Since the bases are equal, so you can simply add the power. Okay, now one question that usually students ask me is, sir, how did you come to know that 32 can be written as 2 to the power 5? So I'm going to give you a very frank answer to this. You just need to know a couple of things. You just need to know them, guys. Like everything can't be very, I have to be very straightforward. You just need to know a couple of things. I'm really sorry. There is no explanation to this. How did I come to know that 32 is 2 to the power 5? I just know it, that's it. It's like when you do the verbal part, the English part, so you happen to know meaning of certain words, right? You just know, that's it, because you have read it in the dictionary, or you must have come across those words in a newspaper or an online article. You just know those things, that's it. So you need to know a couple of things. I'm assuming that you just know a little bit about maths. All right. Anyways, so this is the first question. Again, I have simply used the properties, nothing else. Okay. So let me remove this from the board. Now it's time for question number 2. What is question number 2? Question number 2 is 25 to the power minus 3 by 2 whole to the power n is equal to 5 to the power 6. Find n. Okay. So you know the properties. This question requires a couple of properties from the 6 properties that we have discussed. Pause the video, try the question yourself, and play back the video. Alright, let's see what we can do. Now, if you want to compare, remember the first thing, if you want to compare two expressions, the first thing is that the bases have to be equal. Like I can't compare 25 to the power something with 5 to the power something. That's not possible. I need to have the same basis. Okay, I need to have the same basis. So what can I do is I can write 25 as 5 square to the power minus 3 by 2 and whole to the power n. Then I'll be using that property a to the power m whole to the power n in this portion. Okay, I'm not considering n as of now. So a to the power m whole to the power n is a to the power m into n. So this will become 5 square into 3 by 2 and I'm gonna put whole power to n. Right, now this is 2 into 3 by 2, so these two are gonna get cancelled, and this will simply become 5 to the power 3 whole to the power n, which is equal to 5 to the power 6. Again, you can use that property a to the power m whole to the power n, that is a to the power m into n. So 5 to the power 3n is equal to 5 to the power 6. You have the same basis, compare the powers, so your n will simply become 2, and that's your answer. So again, simply using the properties, nothing else. All right, let's move on to the third one now. All right, third question is, which of them is greater? I'm writing the two expressions, minus 2 cube and minus 4 to the power 4. Question is, which of them is greater? All right, let's see. Now you must have studied this principle. So if you are from Indian curriculum, then you must have read this principle which goes by the name of BODMAS. And if you're from if you're an international student, then you must have read that same concept under the name of PAMDAS. Okay, so if you have started your preparation for GRE or GMAT or SAT, so you would have naturally come across this term, that is PEMDAS. So let's see what these terms are. Basically, they are one and the same thing, it's just that the naming is different. There is no difference as far as the concept is concerned. Okay, so don't worry about that. So BODMAS basically stands for bracket of division, multiplication, addition and subtraction. And when you talk about PAMDAS, PAMDAS stands for parenthesis, exponent, multiplication, division, addition and subtraction. Now just realize a couple of things here. Parenthesis is just a fancy word for the term brackets, right? Parenthesis also means bracket, so there is no difference. Of and exponents are one and the same thing. We use of in India. The only thing that has changed is that they have like reversed the order of division and multiplication. Now, does that really make any effect? For example, if I have a number 8 into 4 by 3. Now, whether you write this as 8 into 1.333 or you write this as 32 by 3, they both will give you the same result. The point is, whether you divide the expressions first or whether you multiply the expression first, it really doesn't matter. So whether you do multiplication division or division multiplication, it's one and the same thing, so don't worry about that. All right, so let's see. So when you say minus 2 whole cube, now what this is, I'm really sorry, I haven't finished with this. So this basically tells you the chronological order in which these operations are supposed to be used. This basically tells you the chronological order in which these expressions are supposed to be used. So first you'll solve the bracket, then off, then divide, then multiply, then add, and then subtract. Same thing, you're gonna first you're gonna solve the parenthesis, then the exponent part, then the multiplication, then division, then addition, and then subtraction. Okay. So when you say minus 2 cube, this is inside the brackets. You're supposed to solve the bracket part first. So this will basically become minus cube into 2 cube. So minus cube is minus, or you can write minus, instead of minus cube you can write minus 1 cube if you're not very comfortable just with the negative sign. So minus 1 cube is minus 1 and 2 cube is 8. So this is minus 1 into 8, which is minus of 8. Whereas in this case, that is minus 4 to the power 4, this is not inside the bracket. I can rewrite this term as minus 1 into 4 to the power 4. What is 4 to the power 4? That is 256. So this is minus 1 into 256, which is minus of 256. Remember that in this case we do not have bracket, guys. We do not have brackets. Okay. So your answer simply becomes minus 256. Now which of them is greater? Minus 8 is greater. Okay. Minus 8 is greater. It's not minus 256. Don't commit that mistake. Alright. So in this question we have understood a concept also that is related to BODMAS and PAMDAS. Alright. Alright. Let's move on to the next question, that is question number 4. So question number 4 is again, which of them is greater? And it's 200 to the power 400 and 400 to the power 200. Okay, so there are like a couple of ways of solving this question or questions like these. I'm going to like explain both the ways to you and you're free to choose your own way. Okay, it doesn't really matter. So on the left hand side, or the left expression that I have, is 200 to the power 400, and I'm not going to change this. I'm going to keep it as it is. But on the right hand side, or the right expression that I have, is 400 to the power 200. Okay, so I can rewrite this as 400 as 20 square to the power 200, and I can use the property a to the power m to the power n is a to the power m into n, and this expression will become 20 to the power 400. So you can see it for yourself which of them is greater, and it's 200 to the power 400. Now it may happen that it doesn't strike you that 400 is a square of 20. It may happen that, okay. So what can we do? What else can we do? Is there an alternate way? So yes, there is an alternate way. Okay, understand this principle first of all. So if you write 6 to the power 4, if you write, let me put brackets around 6. If you write 6 to the power 4, then you can rewrite this as 2 into 3 to the power 4, which you can also rewrite as 2 to the power 4 into 3 to the power 4. And I can prove this, that 2 to the power 4 into 3 to the power 4 is equal to 6 to the power 4. Now what does 2 to the power 4 means? 2 to the power 4 basically means you're going to multiply 2 4 times. What does 3 to the power 4 means? You're going to multiply 3 4 times. I have 4 2's, I have 4 3's. Can I say if I'm going to multiply a 2 with 3, I'm going to get 6? If I'm going to multiply a 2 with 3, I'm going to get 6, right? So I'm going to multiply 4 2's with 4 3's, I'm going to get 4 6's. So that's 6 to the power 4. Okay? So it's one and the same thing. What I'm going to do is, I'm going to rewrite this expression as 2 into 10 square to the power 400, which is 2 to the power 400 into 10 to the power 800. Okay, so in this part I have directly used that property, a to the power m whole to the power n is a to the power m into n, because I have used that property in almost every question, so I believe that you guys must have remembered it by now. Okay, coming to this 400 to the power 200, this will become 4 into 10 square to the power 200. So this is 4 to the power 200 into 10 to the power 400. Okay, now we'll be concentrating on this and this expression. Okay, now 2 to the power 400 I can also rewrite as 2 to the power 4 whole to the power 100, basically going the other way around, that is a to the power m into n can be written as a to the power m whole to the power n. 400 is 4 into 100, so that will become 2 to the power 4 whole to the power 100, and 4 to the power 200 is 4 square to the power 100, again using that same concept. Now what is 2 to the power 4? That's 16, so that's 16 to the power 100, and what is 4 square? That is also 16, so it's again 16 to the power 100. So these two are equal, so cancel them. Now which of them is greater, 10 to the power 800 or 10 to the power 400? 10 to the power 800. So again A is greater. Again A is greater. So the point is, you need to solve, you need to think. Unless and until you start thinking in exponents, this is one of those chapters where you need to actually start thinking. You won't be able to solve a question, right? Alright, no problem, let's move on. Let's solve, we'll be solving a couple of more questions. So let's come to question number 5. So question number 5 is a simple one, I believe. You need to simplify p to the power minus 2 by 3 divided by p to the power 3 by 2. Okay, I would have made this question a bit more difficult. Let me do that. Instead of giving you expression like this, let me give you the expression as simplify p to the power minus 2 cube root of that divided by p cube and square root of that. Simplify this expression. Okay, so let's see, we're going to take them one by one and we're going to decode them. So what are the properties that I'll be using here? In this case, I'll be using property number 4 and property number 5. That is a to the power minus m is 1 over a to the power m, and mth root of a is a to the power 1 by m. Alright, let's see. So we're going to start with the numerator part first. So p to the power minus 2 and there's a cube root of that. This will become p to the power minus 2 whole to the power 1 by 3, which will become p to the power minus 2 by 3. Okay, so now let's come to the denominator part. So this will become p cube and we are doing square root of it, so this will become p cube whole to the power half, so this will become p to the power 3 by 2. So this expression is nothing but p to the power minus 2 by 3 divided by p to the power 3 by 2. Now how do we solve this further? We solve this further using that second property that we discussed, that a to the power m divided by a to the power n is a to the power m minus n. So this can be written as p to the power minus 2 by 3 minus 3 by 2, which I can further rewrite as, by taking LCM in the powers, I'm going to take 6 as my LCM. This will become minus 4 and minus 9. So this will become p to the power minus 13 by 6. P to the power minus 13 by 6. So you can leave it as it is, but I doubt you will get option in this form. You will have option in something like this. So this is like p to the power minus m, right? M is 13 by 6. So this will become 1 over p to the power m. So p to the power minus 13 by 6 will first become 1 over p to the power 13 by 6, which you can also rewrite as 1 over p to the power 13 whole to the power 1 by 6, which you can also rewrite as 1 over p to the power 13, and you'll be doing the sixth root of this expression. So you will get your answer, like you'll get your option in this form. So it's basically like simply converting from one form to the other, nothing else. This sometimes scares people, no doubt in that. All right. Okay, so let's do one thing. Let me keep it till here for this video. Okay, otherwise it's gonna be pretty long video. I don't want to bore you guys also. So let's keep it till here for this video, and in the next video I'm gonna start from here itself. I'll be solving like a couple of more basic questions. Then there are some important results. Then there is the concept of rationalization, and then probably we are done with this chapter. All right, guys. So this is just the video number 1, the basics of exponents part 1. So after this there will be like a couple of more videos on exponents. Okay, thank you so much guys, keep watching and keep learning. Thank you again.